Welcome to Notebook 33, System Message. In this notebook, you're going to learn about one of my favorite techniques and levers to use when working programmatically with large language models, the system message, which is going to allow you to define an overarching persona or role for your chat models. By the time you complete this notebook, you will learn about the chat message type system message. You'll be able to define an overarching role or persona for chat models. We'll investigate and you'll understand more the effect and limitations of various chat message types when interacting with the chat model. And finally, you'll use the system message to create a variety of LLM assistants focused on specific domains. To begin, we will make our imports. Excuse me. You'll notice this time we're just kind of importing some of the vanilla things. We don't have anything additional or new to import in this section. We will instantiate our LLM instance per usual. Let's talk a little bit about system messages. In addition to human and AI messages, which we've explored in the last couple of notebooks, a third major kind of message that we can utilize in our prompts is called the system message. The system message is a preliminary statement or a contextual cue designed to orient an AI model's response towards a specific framework or understanding of a task. There's no hard and fast rules about what belongs in the system message, but typically we should consider it primarily to set the role of the model or any context that's going to apply to all of its responses. Chat models during their instruction fine-tuning will have been trained to have a default system message. Typically, it's going to be something to the effect of, you are a helpful, friendly assistant who always does your best to, etc., etc. However, we can provide our own as part of our prompts. One common use of the system message is to supply the overarching personality and personal details that we want the model to portray when generating responses. Just to get started, and as a simple example, here we're going to create a system message specifying the model should generate responses as if it were a pirate named Sam. So in order to leverage the system message, we can use chat prompt template just to kind of keep you on your toes about the different approaches. We're going to invoke chat prompt template directly here instead of using the from messages method, although that would be equivalent. And we're going to use the two tuple format where we use system now as the first item in the two tuple. Just like we saw that LangChain core messages had human message, had AI message, there's also a system message class constructor there, so you can use that syntax as well. But here we're just going to use the two tuple format. As a system message, we are going to specify you are a pirate. Your name is Sam, you always talk like a pirate. And then we're going to complete our prompt template with a human message that parameterizes the entire prompt. We're going to construct a simple chain with our LM instance in an output parser. And here, if we invoke the chain, we can see that our response, which I won't actually read, but you can yourself, it seems like the model is definitely, when asked who it is, speaking like a pirate and identifying that in fact they are Sam. And it's very clear that the model is representing itself as a pirate named Sam. Additionally, if we provided a second prompt here, which has nothing to do with its identity, it has nothing to do with us asking who it is or what its name is, you can see that given the prompt to give us a short description in the city of Paris, the model is still responding according to the instructions that we specified in the system message, namely as if it were a pirate. So we did this a little bit in the previous notebook with few-shot prompting, where we kind of explored the sort of impact and limitations of the impact of few-shot prompting on model responses. Let's do something akin to that here with the system message. So let's try to reproduce some of the behavior that we attempted in the previous notebook, namely getting the model to mirror back whatever we say to it, but in uppercase. As you remember in the previous notebook, we attempted this with some success, but also with some obvious and kind of immediate limitations using few-shot prompting. Here, we're going to set a system message where we say you are an incredibly simple text repeater who repeats back anything said to you, but in uppercase. And then we construct the rest of the prompt template by parameterizing the entire prompt that we'll invoke with. We construct a simple chain, and we begin our exploration by sending out the word hello, and it seems like that works just fine. If you remember in the previous notebook, when we sent in NVIDIA, we got back the response GPU. In this situation, it looks like the system message has impacted the response of the model more strongly, and we have back NVIDIA. So, just again, to kind of explore the impact and limitations of the system message, let's see how the model does, or what it does when we prompt it explicitly to violate what the system message indicated it should do, right? So we told it, repeat back everything to us in uppercase, but now we're saying, don't repeat this back to me. It looks like in this situation, at least, the system message has demonstrated having more impact than the final prompt that we sent in, because it says, don't repeat this back to me, all in uppercase. So it would seem, right, based on kind of this very lightweight investigation into the impact of the system message, it would seem as if the influence of the system message is quite strong. But just to be clear, however, it's not ironclad. Consider the response to the following prompt. This one, don't repeat this back to me and don't use any uppercase letters, right? We're being even more explicit about violating the instructions in the system message. And here we see, I will not repeat back what you say, and I will only use lowercase letters. Okay, so again, just in our kind of lightweight explorations, it would seem that the system message, at least in the examples we've given here, is a more reliable and powerful way to impact model behavior compared to few-shot prompting alone. But we can definitely see that it has limitations and should never be considered to be some sort of ironclad approach to impacting the behavior and responses of a large language model. So just to summarize, at this point in our work with chat models, we've utilized 3 different roles. The human role, which is meant to indicate a human response interacting with a large language model. This is typically a prompt or a query. We've looked at the AI role, which is understood to be associated with responses from the large language model itself, even though we can author these ourselves for the sake of examples or for other reasons like conversational history, which we'll look at in a couple notebooks. And now third, the system message that we can say is meant to define the overarching role of the large language model. So just some general guidelines for using various message types. We should use a combination of our human message prompts from the end user, human AI example interactions, aka few-shot examples, as well as system messages to influence large language models toward what we want them to generate. Especially given that every chat model is going to have at least a slightly and sometimes drastically different orientation, depending on the model itself, depending on how it was trained, depending on how it was instruction fine-tuned. It'll have a different orientation towards each kind of message we might send it. And we just can't give any hard and fast rules about exactly when and where to use each of these tools that you have at your disposal. That said, right, in addition to the main takeaway, which is like, you got to experiment and see for yourself, there are some rough guidelines that we're willing to pass on that are reliable and good as a starting point. The final human message, which is typically the end user provided prompt, it really matters a lot. It's rare, although we did see an example of that above, but it's rare the model's response would not meaningfully take into account this message, right, when generating a response. It's really important, that final message. The system message definitely has a large overarching impact on the model's generation for scenarios when you want the best guarantees, although again, these are not ironclad guarantees, but when you want the best guarantees about how a model responds, definitely consider setting the system message appropriately. And in practice, much like in earlier sections, we saw that our prompts and our prompt templates can get very large and explicit and specific. System messages themselves can also be very large, very specific, and sometimes you'll even see that system messages themselves will kind of spell out example interactions. Now, it's worth highlighting that within the context of a single system message, right, we're not providing actual human AI message interactions, okay, but in kind of a long form piece of text, sometimes a system message will show, just kind of spell out in strings like what a human would say, what an AI would say, as a few examples. You'll see this a lot. So, just as we've kind of indicated with your prompts, it's okay to go large and to iterate and get as specific as possible. You should definitely consider the same to be true for system messages. And then, finally, in terms of these sort of guidelines, few-shot prompting, in our experience at least, tends to work best in combination with the system message and in combination with specific end-user prompts. We found that you should explore the use of few-shot prompts, especially when specific examples are crucial for achieving the desired output, format, style, or accuracy. So put it another way, the final prompt, of course, always matters. I recommend turning first and foremost to the system message. There's a very good chance that you're going to want to utilize it in a lot of the scenarios that you're using large language models for. Don't be shy about using it. Don't be shy about spending time iterating on the system message. And then if you find it to be helpful, oftentimes after you've established a main prompt or a system message, you may very well find it helpful to add additional few-shot prompts, and especially in the context where you might want to use the same base prompt or same base system message for a variety of different scenarios. Being able to swap in different few-shot examples, as we looked at in the previous notebook, can be a really powerful tool. Okay, so one of the great things about the system message is it's actually really easy to use in spite of its power. Here's an exercise for you that showcases one of the main reasons why you might want to use the system message. So your goal for this exercise is to create 3 different LLM chains that will respond differently to the following prompt. Right? The prompt is going to request to be told about South Korea in less than 50 words. We can define that here. And you can imagine this yourself, right? There's a lot of different ways to respond to this prompt. And depending on your application, you very well may want to focus or highlight on very specific aspects of, in this example, South Korea, right? And you can use the system message to hone in the response of your model in directly the direction that you're interested in. So here, for this exercise, we're defining three different these are just strings, in fact, but we've got a string describing a historian, we've got a string describing someone who would be an economist, and we've got a string describing someone who would be a geographer. And for you, your goal is to create three different large language model chains, all right, that would respond differently given the same prompt. One of them should respond as a historian, one as an economist, and one as a geographer. Okay, so take some time to do this exercise. You'll kind of need to review some of the things you've done earlier in the workshop with chain creation and prompt template construction. You'll be explicitly using the system message for the first time. Hopefully what we've provided you here in the exercise scaffolding will be enough to get you going. Pause the video when you've had a chance to complete that. Come on back. We'll take a look at the solution together. All right, good luck. Okay, hopefully you had fun with that and were able to get some firsthand experience about how you can really shape and specify the kinds of responses your model will generate, even given the exact same prompt. Here's how we approach this solution. You may have done it somewhat differently, which is perfectly fine. But we started with a single prompt template, and it templatizes not only the prompt, but also the system message. Perhaps this didn't occur to you, but in a prompt template, we can parameterize pretty much whatever we want. So we use chat prompt template from messages, and we parameterized not only the prompt as we typically did, but also the system message. So in this way, we can reuse the same template. Next, we created three large language model chains, one for each system message. You almost surely didn't do this because we haven't discussed it, but we wanted to kind of take this chance to introduce just another kind of helpful LangChain piece of functionality. But we're using the templates.partial method, and what this allows us to do is render one of its template values, in this case the system message, and it allows us to specify this at template creation as opposed to waiting to specify it at chain execution time. And again, you definitely didn't need to do this, but we wanted to demonstrate its use. So here we're creating three different chains, historian, economist, and geographer, and we're using our template, this one here, and we're piping the template into the LLM, into the parser. Okay, now assuming we had not used this whole partial thing, let's just imagine it's not there for a second, then given historian chain, we would actually have to specify the system message, which we have parameterized here, at the time of chain invocation. But instead of doing it then, right, we're using this partial method on template to, let's say, pre-specify that system message, right, which is expected here, should be set to the value of historian, which is this string here. So in this way, we're left with a chain that already has the system message defined, and that leaves us with only the prompt that we need to explicitly define when we invoke the historian chain. We did the exact same thing with the economist chain and geographer chain. Again, totally optional, but it just kind of occurred to us that this was a natural time to run these three chains in parallel. Not really much of a point, but again, kind of to review it, it occurred to us very much that these did not need to happen in serial order. So, we just went ahead and created a single parallel chain where we are getting the response from all three of our chains in parallel. With this chain now, which is actually a parallel chain, we're able to invoke it with our single prompt. And then with our response, we just loop over it. We did a little formatting just to make it easier to see. And we can see that we have a roughly 50-word response about South Korea from the perspective of a historian, one from an economist, and one from a geographer, and it worked just fine. Again, lots of ways you could have approached this. We kind of went out of our way to both review some concepts and show some additional ones in our solution, entirely not necessary, but a couple of little details you can pick up there, and hopefully the review of like the parallel piping, the parallel chaining is a helpful bit of review. Okay, so in summary, the system message is a really powerful and also relatively easy to work with tool, and at this point in time, you know how to use it. So in the next notebook, we're going to continue working explicitly with the various chat message types we've been discussing in this section, but in service of a powerful and popular technique called chain of thought prompting. Okay, so I'll see you in notebook 34, where we will discuss chain of thought prompting. Okay, see you there.